3 peaks in the distribution. And if you control the time you eat lunch, I mean, if you're not careful about that and you either have an early lunch or a late lunch and it merges in with when you have dinner, well, those 2 peaks start to interact with each other, and indeed, you can have a lot of trouble with that. But if you don't, and if you control the time you eat, actually in this simulation anyway, we actually have 0, 0, and 4, which is really not bad. And then this last line here is essentially you control the amount you eat as well as the time you eat. And if you do that in this simulation, indeed we get 0, 0, and 0. So we start to see that this model has some interesting and complex behaviors. So let me just zoom in on this. Here's the initial 60 days. And in this case, although it's not particularly realistic, it is interesting in my opinion. This is sort of day 0 here and day 60 at the end here. And in this run, essentially this patient is increasingly hurting himself, because in these 60 days his numbers, and this is the same graph shown in profile, highlighting those bands. So this is 15, this is 20, this is 30 here, right? So, and there's actually also, if it goes below 4.5, we actually might identify too low blood sugars as an issue as well. In fact, that's one of the major issues. We're primarily in this simulation, and it's just a simulation. It's not like we're saying that there's anything more than that. What we're trying to do is demonstrate the capability of the model rather than anything else. So we get numbers like this. As I say, we have 12, 27, and 51 here. With these various things like regulating diet, you can see big improvements, but we still have problem areas. This is the one that works the best, in which we are regulating